Alright, this is a CONUS 2 plot. Merged reflectivity composite, no QC. Wednesday, the 16th of October. It's currently 14:13 UTC. What are those short dashes? That is seriously interesting. There they are. It's a line of them. I'm wondering if it's not the daylight line or some artifact of that. Those artifacts are still present. I'm still wondering if it's not. This is the 6 km radar mosaic for continental US. An XRAD 1 kilometer mosaic. Alright, this is the United States radar mosaic from NU weather, whichever that is. You can still see those artifacts streaking across the country. There they are. There. What are those? Alright, this is the National 3D radar. It's interesting, whatever this is, it pops up in North Dakota. It's probably around that oil field. That oil spill. What's this popping up in northwestern Montana? Something started on the edge of Colorado and then was gone. That was overnight. But look at how those circular blobs are firing up. And notice how it's steering that weather. And look at how straight that line is. This is going to come up numerous times. That is an electromagnetic field line. It's odd that they're going to stir the moisture with it, but we go to other images. It'll be clearly evident. Alright, this is a regional 3D plot. 16 October. Once again. I have to see where that oil spill spot is, but this is the Bakken area right here. This is regional radar northwest continental US, 16 October. If this is the radar net, how come this just magically pops up? Why aren't we already seeing? So, unless the radar is the precipitation itself, there is cloud cover there. That just seems on demand. Alright, this is recent infrared satellite stills, animations, and whatever those linear features were that we're traveling across are not highlighted in this at all, so they have no heat signature or words related to the other effects of the other instrumentation. There is no related display. Region around. Okay, this explains that snow we just saw. Bam. That makes sense. But what was that feature in North Dakota? Why did that all of a sudden just pop up? There's that magnetic field line. They're right there. Boy, this is sort of complicated. Morphed integrated microwave image. And CIMSS, total precipitable water. Global. Current time, Wednesday, 16 October, 14:24 minutes mean time. Check out this anomaly that pops up in Africa. Wow. It's not like a one-time thing because it begins and then it gets larger. zap. Is that a form of discharge or something? Ionic exchange. There's something about Africa, right, in this region, and it's been followed through multiple other people. Astro Traveler pointed this out in numerous parts of his videos about how there is an electromagnetic influence in this part of Africa. And on the whole, we're getting this very phenomenal shit out there. Right, this is the GOES infrared satellite for today. This is an excellent example of that field line. It's a magnetic influence, so it's clarity in the sky, absence of clouds. It's pushing that moisture. Same way it would with it's taking over the jet stream. The jet stream no longer exists. It's probably cause temperatures. Plus the electromagnetic influence from planet X, which has been throwing everything to the solar system out of whack. This is the GOES Northern Hemisphere water vapor satellite image, starting on the 15th of October, running to today. That is so cool. Of course, the more white, more water vapor. We'll go back and look at a infrared image that will show. You notice how this is not moving. This is the equatorial belt. Right? This is not influenced by wind. These are stationary. Stationary in place and cooking up water vapor. And look at these complex mixing patterns. Right? There are two magnetic poles there. This is a field line. And it's running right up to the pole. What about this guy right here? You see these permanent fixtures begin to stand out over time, and it becomes undeniable. This is a really cool plot. I was there before. You can actually see the depth in it. These are what are called flux tubes, and it is a connection to the sun. This is also an area right around in here. The entire summer there was a spinning feature that set up our entire summer, in which we had that atmospheric river, which we're seeing displayed here, right along that similar path to the south. Okay, this is the GOES West full disk shortwave IR, 15th and 16th of October. Of note, if you look at the southern hemisphere, we've got these dual spinning features. The stationary equatorial, let's call that a moisture explosion, constantly just cooks up every day. We have a swirly feature northeast of Hawaii, within this hook range of the Bay of Alaska. Another spinning feature, and once again, there are those field lines. So just looking at this is a dual pole down in the southern hemisphere, and this is a single pole in the northern. Astro Traveler. This is your realm. Turn it over to you. Same satellite, different image. Water vapor, 6.5 micrometers. Isn't it interesting that over the Pacific Ocean, there's no water vapor. Clear skies, I suppose. But this really shows the highlighted aspects of that mixing of those features. And actually, this is got a third, three. And notice how this is beginning to want to spin the opposite direction. Now, normally in atmospheric pressure conditions, you have rotations for low pressure cells versus high pressure cells. And I don't remember the direction, but there are opposite spinners on the northern hemisphere, and they spin opposite on the southern hemisphere. We have dual same direction spins in the southern hemisphere. Counter direction spins coming out of this feature, top of this feature. This nice little wormhole on there, see that berries over there. So it's not good for us, but at least you get to see what's going on. Okay, so this is the visible light aspect of the satellite of the other two images. Wow, it'd be kind of nice to be able to overlay all three of them. It'd be a little complicated to analyze, but this gives you the day-night cycle. Alright, this is long range, or long wave, excuse me, IR, 10.7 micrometers. Less identifiable features, so it is a function of wavelength at that range of the electromagnetic spectrum. So less high energy, more low energy. This way, let's switch to the short wave. A bit more information. And back to the water vapor. This is zoom of the water vapor image, southern hemisphere. Speed it up. No, you won't be seeing McGuire or McIntosh giving you this look. Pay attention to this area right here.